Alright, so we're going to divide radical expressions, and we're really just simplifying a fraction with a radical in the denominator. So really we're just going to end up rationalizing the denominator. The only difference is we're doing it with not just a square root, like you already know how to do, but with cube roots and fourth roots and fifth roots and so on. So you can only do this if your radicals have the same index, and they will. I'm not going to give them to you if they don't. I modified my steps a little bit from how I taught this last year, so it's really going to end up with 5, not 6. And so I've got to do this kind of quick with my talking because I'm going to run out of time and have to split it. So pause, back up, rewatch 2, 3 times, whatever. Pause to write down the stuff that I've got written down and digest it. Okay? So steps. I'm going to give them, and then I'm going to give my disclaimer. You're going to rewrite, that looks horrible. Man, it's because I'm in a hurry. I'm ready to go. We're going to rewrite as a single radical. In other words, one big radical with the fraction inside the radical. Simplify if you can. Separate it back out. That means the radical back in the numerator and the denominator. It's going to look like that, unless for some reason the top simplifies out completely and the radical goes away in the numerator. You're going to rationalize that denominator. And that's where the last lesson that I taught, where you're finding those perfect roots, that's where that's going to come in. And in case you have forgotten what it means to rationalize a denominator, all that means is that you're going to multiply by some radical to create a perfect root. So that you can simplify and get rid of that radical. And then the last thing you're going to do is you always check when you think you're finished, see if you can simplify anything else. Now, quick disclaimer. Here's my speedy, quick, fine print, end of the car commercial where you don't know what I'm saying, but I'm going to say it so you can understand it. These first 2 steps, honestly, are not always necessary. You can omit them and go straight into, actually, the first 3, because if you get rid of the first one, you don't need the third one. You can omit this and go straight into here. The only difference is sometimes doing the first one where you separate it and simplify it, it'll make your numbers a little bit smaller. But it's not necessary. You don't have to do the first 3. You can start with step 4. Okay? So I'm going to show you on example 1. Now you've got your steps written so you can follow along because I can't keep flipping back and 2. Your step 1 says to rewrite it as a single radical. So I'm going to do that. I'm going to have 4 times 4x squared over 5x to the 4th. And I'm going to simplify that because I can simplify these 2 things. So I've got, and I can even simplify, well, I'm not going to do that yet. The square root of, x squared over x to the 4th is going to leave me, remember when you divide like bases, you subtract, so it's going to leave me with that. So now I want to take it back apart. Remember the 4 was in my numerator. I got the square root of 4 over the square root of 5x squared. I can simplify the square root of 4. It's 2, right? So 4 times 2 gives me 8. The square root of 4 is 2. 2 times 4 is 8. I can take the square root of x squared. The square root of x squared is x, and that leaves me with x times the square root of 5. Here's the rationalizing the denominator part. I got to get rid of the square root of 5. You already know how to do this. To get rid of a square root, you multiply by the exact same square root. And so I have 8 times the square root of 5 over the square root of 5 times the square root of 5. I'm just going to do it. It's the square root of 25, which is 5. And so I have 8 square roots of 5 over 5x. And then you would just check things on the outside. Can you simplify? And if you can simplify the radical again, simplify the radical again. Okay? There's not room to do 2, 4, and 6 on the front side. I apologize. I don't know why I made that so small. So fold this in half because it is going in your notebook, in your composition book. And we'll do number 2 on the back. Number 2 is the 5th root of 25a squared over 5 times the 5th root of 80a squared. Again, if you want to do this step, now that 5 is in the denominator and that's got an understood 1, so I've got 1/5 and make a single radical if you want to. Simplify what's in that radical. So 25 over 80 will simplify to 5 over 16. And a squared over a squared is 1, so you kind of are just losing that. Now take it back. I'm sorry, this is a 5th root. So now let's take it back apart. Remember that the 5 is in the denominator. So I have the 5th root of 5 over 5 times the 5th root of 16. And here's where I have to rationalize. Here's where I have to multiply. Here's where I'm going to use this. 16 is not in my 5th root column. This is my 5th root. 16 is not there. But 16 will go into 32. It will also go into 1024. You can pick either one. It doesn't matter. I just usually go with the lowest one so the numbers are smaller. So I've got to multiply by the 5th root of something so that I can get 32. Well, 16 times 2 gives me 32. And 5 times 2 gives me 10. So I can take the 5th root of 32. It is 2. So I have the 5th root of 10 over 5 times 2. So my final answer, I have the 5th root of 10 over 10. If you check that, you cannot take the 5th root of 10. If you go back and you do your little factor tree, that's just 2 times 5. I don't have 5 groups of anything. This part is just simplifying, and that's the stuff that we've been doing. Final answer for number 2. 5 square roots of 10 over 10. Sorry, the 5th root, oh my great day in the morning, I can't believe I said that. It's the 5th root of 10 over 10, and that's my answer for number 2. For number 3, I'm going to show you not taking it apart so that you can just see that you don't necessarily have to separate if you don't want to. I could simplify these two if I wanted to. And so the more comfortable you get with this, the more shortcuts or things that you can see that you can do different, you'll find them. So I've got the cube root of 3x to the 4th over the cube root of 5x squared. If I look in my cube root column, 5 is not there, but 125 is, and that's definitely divisible by 5. So I'm just going to go ahead and rationalize. I'm going to go ahead and multiply. I meant to make that a multiplication sign. I've got to multiply by the cube root of something to get 125 because that's a perfect cube. So 125 divided by 5 is 25. And in order to make it a perfect cube, I need 3 x's, and I've only got 2, so let's multiply by 1 more. So now I've got the cube root of 3x to the 4th times the cube root of 25x which is going to give me the cube root of 75x to the 5th. And the cube root of 5x squared times the cube root of 25x is going to give me the cube root of 125x cubed. Simplify it. So if I'm trying to take the cube root of 75, pause this video, step outside, do your little factor tree, and see if you can take the cube root of 75. I don't think we can. I know we can't, because that's going to break down to 3 times 5 times 5, and I can't do anything with that. So I've got the cube root, but I can take the cube root of x to the 5th. I can take out one group of x's. So if I take out 3, how many is that going to leave me on the inside? 5 minus 3 is 2. And then on the bottom, the cube root of 125, the cube root of 125 is 5. So that's going to give me a 5, and the cube root of x cubed is x. One more thing. Check it. Last thing you're going to do, when you get everything out, and the radical is gone from the bottom, check this stuff. X over x is 1. So that divides itself out, and I have the cube root of 75x squared over 5. Final answer. I want to show you real fast before I run out of time and I have to kick over a new video. I can go to my calculator and put in this part without the x's. The cube root, sorry, I did the wrong thing. The cube root of 3 over the cube root of 5, and it gives me this decimal answer. If I do the cube root, hit my fraction button, and do the cube root of 75 over 5, I should get that same number, and I do. So you can know that part of your answer is correct if you just put in the numerical part of the original and the numerical part of your answer, and if the decimal answers are the same, you got it. You're good. All right, I'm going to have to pause and start a new video. I apologize. I promised I would keep them under 15, but I can't do these next 3 examples in 2.5 minutes. So pick up with divide and radical expressions 2 to finish it out.